Okay guys, Chad Meyer here, and today we're going to talk about solving a quadratic equation or a quadratic function. And this might be something that you'll see in a ninth grade algebra final or something along those lines. So let's just start with the equation y equals 2x squared minus 3x minus 8. And I just kind of came up with this on my own. Haven't pre-done this yet, so this might come and bite me in the butt. But anyway, when we do something like that, when we're being asked to solve it, really we're asked to do a couple different things. First thing, we're always going to want to find the zeros. Maybe we want to know what the minimum value of it is. Maybe know what the maximum value of it is. And maybe we're going to ask for the axis of symmetry. Okay, so we'll hit those four things right now. Before we do any of these, or in order to find these, we're going to go through and find the A value, the B value, and the C value. And these three items are used to find the axis of symmetry, and in the quadratic equation to find the zeros. The quadratic formula. Now the A value is always the value in front of the x squared. Call that the coefficient in front of the x squared. In this case, it's 2. It's in front of the x squared. The B value is the coefficient that's in front of just the x, the standalone, and that's this negative 3. It's not 3, it's negative 3. And the C value is the standalone value, or constant is another thing it's called. And that is this right here, which would be negative 8. Okay. And I like to take a little mental picture of what this thing might look like. Okay. So yes, we can always use a graphing calculator, something like this, to type it in there and see what we get. But I know if we look at it, okay, this tells you it's going to be a little bit more narrow than your just x squared parabola. And it's positive, so it's going to be going upwards. Okay. So that tells us right now the max value is going to be infinity. All right. It's being pushed over to the right. Okay, I know this is negative 3, but since it's negative, it's going to be pushed over to the right. So when we actually do this, we're going to see with the axis of symmetry. The axis of symmetry is negative b over 2a. Okay, that's the formula for equals the axis of symmetry. So negative b, well, b is negative 3, so it's negative, and whatever b is, negative 3 over 2 times whatever a is. Let's see, 2 times, and a is 2. Okay, well, a negative 3, well, that's a positive 3. Negative times negative is positive. 2 times 2 is 4. Okay, so our axis of symmetry is 3/4. So that also equals 0.75. So what that means is on our x-axis, okay, there's 1, there's 2, there's 3, there's -1, -2, -3. Our axis of symmetry is at 3/4, or 0.75, which is not quite to 1. So we got a little dotted line going down through there. Okay, the axis of symmetry of the parabola. Remember, symmetry means it's equal on both sides, or even on both sides. It's symmetrical. So this is where it cuts right down through the middle of that parabola when we make it. And like I said, I knew this parabola was going to be pushed over to the right a little bit because the b value was negative. In order to find the minimum value, well, if we realize a parabola, it's shaped like that, axis of symmetry going right down through the center of it. Okay, the minimum value is going to be where that parabola crosses the axis of symmetry. That's going to be the smallest value. So in order to find that, all we do is take our value for the axis of symmetry and plug it back into the x's on the original equation. Okay, so we have the original equation is y equals 2x squared minus 3x minus 8. In place of those x's, I'm going to put the 0.75. Y equals 0.75 squared minus 3. Place the x, 0.75 again, minus 8. Like I said, remember, I did this out just one off the top of my head, so I knew it might get a little messy. Okay. 0.75 squared. Well, 0.75 times 0.75. Oh. For the point, 0.75 times 0.75 equals 0.5625. No way to do that is 0.75 squared. Same thing, 0.5625. So y equals 2 times 0.5625 minus 3 times 0.75. Well, that should be 2.25, but we'll do it on here just for the heck of it. 3 times 0.75 equals 2.25 minus 8. Well, 2 times this thing right here, 2 times 0.5625. 2 times 0.5625 is 1.125. Y equals minus 2.25 minus 8. All right. So let's just put this whole thing here in the calculator and see what we get here. 1.125 minus 2.25 minus 8. And we get negative 0.125, negative 9.125. Y equals negative 9.125. I'm just going to double check my math on that and make sure I didn't type anything wrong in. 1.125 minus 2.25 minus 8 equals negative 9.125. Yep, okay, we got that right. So when we go back here, we know that our minimum value is negative 9.125. Negative 9.125. And that means that this parabola that we're sketching, say we go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. It's going to bounce down around negative 9.125. So just past negative 9. That's where it's going to bottom out at and start to kick back up. That's our, also known as the vertex. That's our minimum value for that function. Okay. Now we got to find the zeros. Well, the zeros are where the parabola crosses the x-axis. Okay. Where does this parabola cross the x-axis? And we call them the zeros because if you think about it, along the x-axis, any point on that x-axis has a y value or an up and down value, you know, how up, how far down, of 0. It's not up at all, it's not down at all. It's right on that 0 line. Okay, it'll still have an x value going to the left or going to the right, but it won't have a value for up or down. So that's why we call them the zeros. So for the zeros, there are a few different ways to do it. I like the quadratic formula. Some people like completing the square. Either one is fine. But I'm going to use the quadratic formula. Quadratic formula is x equals, that's the, you know, along the 0 line, the x-axis line, negative b plus or minus the square root of b squared minus 4ac, that whole thing, everything, over 2a. And if you look at that axis of symmetry formula, negative b over 2a, it is a component. Here's your negative b, here's your 2a, of the quadratic formula. So now let's plug in the numbers. Well, going back to our a's, b's, and c's that we originally did right here. A is 2. I'll rewrite it here. A was 2, b was negative 3, and c was negative 8. So we're going to plug those numbers into the function of the formula and chug them out here. And again, yes, you can do this with your graphing calculator, but this is far more satisfying, at least to me. So x equals negative, whatever the b value is. In this case, it's negative 3 plus or minus big square root, because we're going to put stuff underneath it, b squared. That's negative 3 squared. Just make your life easier anytime you're putting a value in place of a variable. Wrap that value in parentheses, so it just keeps it clean for you. Minus 4, a is 2, and c is negative 8, all over 2, and a is 2. So let's clean this up a little bit as we go. Negative 3 is positive 3 plus or minus big square root, negative 3 squared. All right, and this is, again, why we talk about the parentheses. The negative 3 is in parentheses, and we have the square on the outside. That tells us that everything that's inside the parentheses is being squared. Squared, remember, means times itself. So we're talking about negative 3 times itself, times negative 3. Negative 3 times negative 3 is positive 9. Negative times a negative is a positive. 3 times 3 is 9. So we got 9 minus, let's do this here, 4 times, because we're multiplying here. Anything times you have a value times a value in parentheses, or value in parentheses next to another value in parentheses, you're multiplying. 4 times 2 is 8. Okay, and 8 times 8, we got negative 8 here, but 8 times 8 is 64. I ate and ate till I was sick on the floor. 8 times 8 is 64. But this is negative 64. So I'm going to put negative 64 in here. And I know some people are going to say, wait a minute. This was negative 4. Yeah, I'm keeping the minus there, and I'm going to take care of this now. And we got that all over 4. Well, what is 9 minus negative 64? Wasn't that just the same as 9 plus 64? Okay. Minus a negative is the same as plus. So I'm going to do that all right over here. So we get 3 plus or minus square root of 9 plus 64 is 73. Okay, all over 4. Yeah, remember I said this wasn't going to come out even. This is going to be a little bit ugly. All right. At this point right here, because this didn't come out evenly, they might just say stop. Say this is your zeros right here. Your zeros are, or x equals 3 plus or minus the square root of 73, all divided by 4. What the hell does that mean? Well, excuse me, what the heck does that mean? You know, does that give me an idea of what number that is? No. So I'm going to approximate. Okay, I'm going to approximate. This is not the actual answer. This is going to be about. Okay. So what could the approximate answer of the square root of 73 be? Well, the square root of 64 is 8. Square root of 73, that's our question mark. Square root of 64, what's after 64? Well, square root of 81 is 9. All right. So this is 9 values away from here. 9, this is 8 from here. So this is like right in the middle here, right between the two. So I'm going to say the square root of 73 is about 8.5. Let's guess. About 8.5. Okay. So now I'm going to change this equal sign to a squiggly equal sign, about about 8.5. 3 plus or minus 8.5 all divided by 4. Okay, and here's what, again, this is going to get really about-ish. But 3 plus, okay, this becomes two different things. That's what that plus and minus means. 3 plus 8.5 divided by 4 and 3 minus 8.5 divided by 4. That's what that plus or minus here means. We've got to do it 2 times because, you know, if we look at this parabola, we're going to get 2 zeros. One's going to be on this side somewhere, and one's going to be on this side somewhere. One's going to be a negative value, one's going to be a positive value in this case. Sometimes they're going to be both positive, sometimes they can be both negative. Sometimes you only get one, sometimes you get none, but in this case, we're going to get a positive and negative. Well, what's 3.8.5? That's 11.5 divided by 4. Okay. What is that? 12 divided by 4 is 3. So it's going to be a little less than 3. It's probably, I'm going to guesstimate it's going to be about 2.8. Let's find out. Let's find out how much of a guesser I am. 11.5 divided by 4. Yeah, I could do that all out by hand, but, you know, what did I say? 2.8, 2.875. About 2.875, so almost 2.9. All right, now we got a 3 minus 8.5. Well, we're taking away more than we have, so we're going to go in the negatives. That's going to be negative 5.5 divided by 4. All right. Negative 5.5 divided by 4. I'm going to guess somewhere around negative 1.2. That's my guess, negative 1.2. Oh, I wasn't even close. Negative 1.375. Negative 1.375. All right, so I'm going to kind of do some rounding, at least to the first decimal place. So I'm going to say our zeros are about 2.9 and about negative 1.4. Okay, this is doing it all by hand. Let's plug, now for giggles, let's see what the calculator comes up if we plug this whole thing in. I'll clear all this, y equals, go my y editor, clear all that out. Our equation is 2x squared minus 3x minus 8. Okay. 2x squared minus 3x minus 8. I'm going to graph it. Oh, I'm going to need to change my window. I was doing something else here earlier. Let's see, zoom 6 is standard. All right, so that's what it looks like. Hopefully you can see that. Okay. And trying to move my lamp here so maybe you can get a better look at what I'm talking about here. Maybe that helps, I don't know. Okay, so that's what it looks like. Now we want to find the minimum value. So I go to second and trace, which brings up the calculate function. And I want to find the minimum value. And it says left bound. So now it wants to know, you know, where am I looking on the graph? So I want to make sure that my bounds are encompass where the vertex of the parabola is, or where the dip's the lowest. So I'm going to look for, okay, so I can see where there's one mark. So that's my left bound. Enter. Now it's asking for the right bound. I gotta go to the other side. There it is. There's my right bound. So now I've encompassed, and you can see in the calculator shows the arrows, the area in between those two arrows. Yeah, it's down in there. Enter a guess. And it's guessing negative 9.125. Well, if we look at that, negative 9.125 for our minimum value. Holy cow, we did it right. All right, let's talk about the zeros. All right, so we go to 0. And again, we're going to get that left bound and right bound. And we want to have the left bound be above here, and our right bound be below here, because it's going to take the area in between that. There's the first point, enter, or the bound. Below. Okay, it's going to say you just wanted to guess. Now let's remember what we had. We guessed around negative 1.4. Okay, and that was all based off guessing the square root of 73. So if we're close to that, I'll be happy. Negative 1.4. There we go, negative 1.386. That's close enough for me, that's for darn sure. And last time we're going to do the other 0. And we're going to get that left bound, right bound. Now this time, the left bound is going to be before or underneath, and the right bound is going to be above, because again, we want to find the area in between these two right here. So I'm going to bring it all the way over. Come on. There's the first one. Left bound there. There's the right bound. And again, now we're looking at that area in between those two arrows, which is where it crosses the line, crosses the x-axis. And we had 2.9, so again, we're looking for a number close to 2.9. 2.88. Well, heck, that's, again, certainly good enough for me. So, because we got the minimum value right, we know we got the axis of symmetry right. So again, our axis of symmetry, we had 0.75. That means on that graph, the parabola bounces around the imaginary line 0.75, going up and down. X equals 0.75. Our max value of the parabola, well, it's going to continue to go up and up and up and up. So the max value is never going to end. So we say the max value is infinite. The minimum value, it bottoms out down here at y equals negative 9.125. That's where that bottoms out. And we got the zeros. And again, yeah, this was an ugly equation. So, a function. So we guesstimated at negative 1.4 and positive 2.9. We got the actual values, but they were dang close to that. So anyway, that's a quick and dirty overview of how to play with a quadratic function. If you have any questions or whatever, put them in the comments below. All right.